virtual machine. And well, if independently we do the same thing between Python and CLR, compile here a version of PyPy that will run inside of .NET, then I believe that you can actually compose the two translation automatically. You could have PyPy running in the two environments. Then you can add, for example, I don't know, some kind of translation mechanism, sockets or shared memory, something maybe a bit high level, to allow communication between this and this in a fairly general way. And then by compiling the two translation together, so only using compiler techniques, actually generates the actual bridging code, marshalling and unmarshalling necessary. So only by having written on the one hand this thing and on the other hand this thing, you can compile the composition. And the composition then doesn't even have to be aware of what a Python class is. It can bring you from a Java class to a .NET class directly. So it means essentially that, I think that this kind of tool of technique can be used to help in issues like software composition. In this example, you would be able to bridge. You would be able to take any Java class and map it to a .NET class or vice versa, insofar as what you're interested in maps or goes through the notion of a Python class. If there are attributes common here and here that have no natural equivalent in Python, they are lost by the translation, obviously. So this is my point of view of how you could actually, how you don't need a standardized low-level layer for communication. You can do so by composing high-level concepts, transformations. And that's it.
All right, questions? Oh, these guys are tired.
I guess I'm curious what the ultimate compiled code performance will be once you get to the point where you actually have a JIT.
Well,
you don't have anything.
Yes, I don't have any figure.
You don't have any data yet, so we can't.
I'm confident that we can recreate something which can itself be a JIT that produce code that is as efficient as what we currently do with the Psycho project. This creates, C equivalent code, if you wish, putting enough effort into optimization, backend optimization.
Do you have a comparison between the C Python performance and the generated
no,
PyPy performance?
We are not able yet to
generate
there
yet? Yeah, okay.
For the whole project.
I just wondered to what extent concrete decisions about representations in the interpreter affect the generated code. If you decide that you're going to represent closures in a particular way, does the abstract interpretation somehow optimize that for you? You're still sort of left with fundamentally this is the way you've chosen to structure the interpreter such that it has an impact on the performance and generated.
The early design decisions are essentially what we allow in our Python, so in the restricted version of Python. And this contains things like classes, attributes. You can have function closures as well, but not creating closures on the fly because this is not easy to map to C. So it's kind of a mix. Whatever is easy to map to C, we will allow it. So we don't, I cannot say now because we don't have figures to translation of the full interpreter.
All right, thank you. And now for yet something even more completely different.
Okay, I am